Good day, everyone. So, in today's lecture, I'll be explaining the concept of rate law under reaction kinetics. Rate law states that the rate of chemical reaction is directly proportional to the concentration of the product of the reacting species raised to the appropriate power of the reacting species. Okay, so what rate law is trying to tell us is if I have reacting species, reactants, let's say reactants A and reactants B. Let's say A reacts with B to yield a product C. And let's assume that the stoichiometric factor of A is 2 and that of B is 3 to yield C. This type of reaction in chemistry is called an undefined reaction. And the reason why we call it an undefined reaction is because we are using alphabet to represent the position of species in chemistry. So it is called an undefined reaction because the species that ought to occupy all these positions are not specified. And that is why this is called an undefined reaction in chemistry. So let's assume A reacts with B to give C. What rate law is saying is that the rate of chemical reaction is directly proportional to the concentration of the reacting species, concentration of A raised to its appropriate power, X, concentration of B raised to its appropriate power, Y. This is what we call rate law in chemistry. And when we remove this proportionality sign, we are going to introduce a constant. So R equals K, concentration of A raised to its appropriate power, concentration of B raised to its appropriate power. Now, under this rate law, this R is the rate of chemical reaction. The K is called the rate constant. X is the order of reactant A. Y is the order of reactant B. Now, anytime the order of the reaction is specified, the name of this constant changes. It changes to specific rate constant. Why? Because the order of the reaction has been specified. And you have to take note that these stoichiometric factors or the mole ratio of the reactant can only be equal to the order of the reaction when the process is an elementary process. So when the process is an elementary process, we can say X is 2, Y is 3. But if the process is not an elementary process or elementary reaction, they are not equal. And these 2 is the stoichiometric factor of A, and the 3 is the stoichiometric factor of B. And they are the one that determines the molecularity of the reaction. So if I want to calculate the molecularity of this reaction, all I have to do is I'm going to add the mole ratio of A with the mole ratio of B. It simply means in this undefined reaction, the molecularity of the reaction is 5. That is 2 plus 3, and that is 5. But if the process or the reaction is an elementary reaction, the order of the reaction will also be 5. Okay? So the arithmetic sum of the stoichiometric factor of reacting species is called the molecularity of the reaction. While the sum of the order of A with the order of B is called the total order of the reaction. So the total order of the reaction is equal to X plus Y. That is the total order of the reaction. Now there are some key terms that they do use under rate law. Terms like anytime they say a reacting species or the rate of chemical reaction is independent on a particular reactant species, it means the order of that reactant is 0. So if I say the rate of chemical reaction of this reaction is independent on the reactant A, it means the order of A is 0, X is 0. And if it is B, it means the order of B is 0. Okay? Now, anytime the total order of the reaction is 1, the reaction is called first order of the reaction. And anytime it is 2, it is called second order of the reaction. Anytime it is 3, it is called the third order of the reaction. Now, how do we now calculate the order of a particular reaction if the reaction is not an elementary process or elementary reaction? Now, let's consider this example. Now, the question says, in this reaction above now, so we have the rate of formation of C for the above hypothetical reaction is found experimentally to be independent of the concentration of B. It means the order of B is 0. If the concentration of the reactant A is doubled, the rate of reaction increases by a factor of 4. What is the order with respect to A? So the first thing we are going to do for this question is we have to write our rate law. So our rate law will be R, rate of chemical reaction, equals K, the rate constant, concentration of A raised to its appropriate power, the order, concentration of B raised to its appropriate power, which is the order. But from the question, we've been told that the rate of formation of C is independent on the concentration of B. It means the order of B is 0. That is, Y is equal to 0. So if I include 0, I'm going to have R equals K, concentration of A raised to X, concentration of B raised to 0. And anything raised to 0 is 1. So R equals K, concentration of A raised to X. It means the rate of formation of C only depends on the concentration of A. Okay, so I'm going to call this equation 1. Equation 1. Now, we are given another condition, and the condition is if the concentration of reactant A is doubled. So it simply means this is the first reaction. So the concentration of reactant A is doubled. It simply means A2 is equal to 2A1. Okay, it's doubled. And I'll say the rate of the reaction increases by a factor of 4. It means R2 is equal to 4R1. Okay, so for the next equation, I'm going to include all these parameters. So I'm having R2 to be equals to K, A2 raised to X. Okay, so R2 is 4R1. So 4R1 equals K. And then A2 is 2A1. 2A1 raised to X. And this is equation number 2. Now, to get the order of the reaction, all I have to do is I'll divide equation 1 by equation 2, or equation 2 by equation 1. So divide equation 2 by 1. So if I do that, I'm going to have equation 2 is 4R1 equals K, concentration of 2A1 raised to X, and that of 1 is R1 K, concentration of A raised to X. So from here we have that R1, we cancel R1, so we are left with 4 equals, and then K we cancel K, and if we expand this, we are going to have 2 raised to X and then a raised to 1, a1 raised to x, and then this is a1 raised to x, so that this will cancel this, and then we are left with 4 equals 2 raised to x. And when we make use of the concept of indices, this is going to be 2 raised to 2. 2 raised to 2 equals to 2 raised to x. And when we equate the basis, or we drop the power, we have x to be equals to 2. So if I want to get the order of the reaction, the total order of the reaction, normally, the total order should be x plus y. Okay? And now I'm having x to be equals to 2, but y is 0. So the total order of the reaction is 2. It simply means the rate of formation of C depends only on A, and the total order of the reaction is 2, which is second order of the reaction. And this is how we go about questions under rate law when we are talking about the theoretical calculation under rate law. Thank you very much. See you guys in my next class. I remain Ajadium.